Cutting edge continuous delivery. Why cutting edge? Because automated canary analysis is really something that we don't normally see in the enterprises, at least not in the Netherlands, as far as I know of. And it's mostly something done by companies like Netflix, Netflix and Google, and big companies that have site reliability engineering as a separate team, right? But thanks to Spinnaker, we can do this as part of our continuous delivery as well, without really investing in mathematicians, right? To having a company, because this is really related to kind of artificial intelligence or machine learning, but it's really made easy. I mean, I'm really not an expert in those subjects, so me presenting this kind of is testament to how easy it is. So Spinnaker, what is it all about? It's about fast, safe, and repeatable multi-cloud deployment. You don't have to have multi-clouds, but we often see that companies, especially enterprises, do have multiple clouds, not just because they, for instance, would choose for Azure or for AWS, right? But often they have already something running on-premise, right? Which is somehow also an environment that they still have to support, right? So that in a sense is also multi-cloud. So let me first quickly introduce myself. Maybe that's the first step. Not working. Okay, now to this. So who am I? I'm a solution architect at Pivotal. I work in the application transformation team for EMEA. So what do? We go to our clients, our customers, all across EMEA to help them move their workloads into the cloud. We have a platform called Cloud Foundry, which includes, of course, Cloud Foundry itself from the Cloud Foundry Foundation, but also Kubernetes, which is actually the PKS thing that we offer. I used to work for JBox at Ordina, which is a Dutch company, so maybe you guys know it, in Belgium. I'm from Belgium, and you can follow me on Twitter as well. If you have any questions after this talk as well, and not here anymore, then you can ask on Twitter as well. So a little bit about Pivotal perhaps. So we have this thing called Pivotal Cloud Foundry, which next to the application service, which is a platform, an application platform, right? It's a bit more than just a container platform. We also have Kubernetes as a service, and we also have Pivotal Function Service, which is a function as a service now. It's running on top of Kubernetes, and it's using something called Riff. I don't know if you've heard about that, or Knative from Google, right? Which is kind of merged these days. And we also offer things like service brokers, which make it really easy to link up your application, which is deployed on the platform, with, for instance, a database or a queue or anything you need to connect to. Okay, all this is running on Bosch. I don't know, does anyone know Bosch? One person? Yeah. Okay, right. So Bosch, interestingly, is based on Borg. And does anyone know Borg? Google, right? And so it's a predecessor of Kubernetes, but Bosch itself is based on Borg. And the reason why that's funny is because Bosch is like Borg++, as in the S is the R+1, and the G of Borg is, or the H is like G+1, right? So they just, funny story, not so funny. The idea of Bosch is that it kind of gives you this abstraction layer of any cloud you want to deploy it on. So you can deploy it on bare metal, on OpenStack, on vSphere, on any cloud that you can think of. Well, maybe not any cloud, it's not something that you grew up in your own basement, but like all the major cloud environments are supported. And that's pretty interesting because it allows you to deploy this application framework, which can be either Kubernetes, Knative or Riff, or Foundry, right on this common foundation. And that's what you're going to see in Spinnaker as well, which is kind of a similar idea, that you abstract away the complexities of your cloud, right? That also means you can work multi-cloud in a really easy fashion. I really have to turn it off. So, do we have a remote control? This?
No, that's not it.
Because I don't have access to that. Anyway, we also have a thing called Spring. Is anyone a Java developer here? Right, so you're probably a Spring developer, right? No? Who is the Java developer and not a Spring developer? So Java E? Or just?
Not sure.
Oh, so what are you looking at?
Sure, see.
Oh, okay. Yeah, so that's also possible. But most people in Java, I would say, are familiar with Spring at least, and mostly are using Spring. Because Spring is like the enterprise framework, which is, it's like super old these days, but it's also very popular because of Spring Boot, which allows you to build cloud native applications very easily with a 12-factor app, and then deploy that like to any clouds that you want to deploy to. Because it's self-contained as well. A bit like .NET Core, although .NET Core also packages the .NET runtime, while Spring Boot doesn't package it too. Right, so the Spring team is also part of it. So enough of the picture, I suppose. Let's move on to what I want to talk about. So when we actually look at the enterprises these days, there are kind of three big trends that we're noticing, right? The first one is embracing DevOps, right? So we're all doing DevOps these days, right? Or at least we think about doing it. And that entails not just culture, because DevOps is bringing people together into one team, so everybody is required to get an idea into production is being put into the same team, right? A bit of the war room mode, just everyone together to get things done. But also the practices, right? We make sure that everything is automated, right? Not just automated testing, but also automated deployment. And that's where continuous deployment comes in. So this is really part of that. So DevOps, the second thing is microservices. So we all start doing microservices, right? Even though that might not be the best thing for us to do, but it's the hack, right? So we all start doing these cloud-native development. Cloud-native development, we go towards distributed architectures, which is a lot more harder to do. You have a lot more floating components, so you kind of have to make sure that you can manage that, right? Now we have a lot more deployments going to the cloud as well because they're smaller, so we gotta have to manage that as well, right? So that's not easy. And then, of course, we want to have these things deployed on a foundation which gives you self-service, and that mostly are cloud providers, right? So in cloud providers, you just have different kind of abstraction levels. Well, I didn't put them here on this slide, but you have things like what I mentioned, like infrastructure as a service, then container as a service, platform as a service, and eventually software as a service, maybe even function as a service. So all these different abstractions. Now, when we were going through all these, when we were actually doing all these transformations, these digital transformations that people like to call, we actually learned a couple of lessons. And the lessons that we learned regarding continuous delivery are really interesting because they kind of teach us things that that if we don't apply these, then we're going to be in a world of pain. Because this new paradigm, this new way of working is really different. And the first thing that we noticed is that the deployment frequency really exploded, right? So it used to be one deployment in a couple of months, and now we see that it's multiple deployments per day, right? At Netflix, for instance, anyone has a guess how many deployments Netflix does a day? More.
6 digits.
No, not 5. But 4,000. Their number currently, their public number is 4,000. But the thing is, they multiply that by, I think, by 2 every year. Yeah, every 2. So every year they multiply that up. So next year it's going to be like 8,000, right? So that's an insane number of deployments. I just don't imagine how many pipelines they must trigger. You know, it's like if you work with Jenkins, for instance, how many nodes, how many slaves you need in Jenkins to just be able to cope with that. So just being able to kind of manage that complexity is very difficult, right? It's not easy. So that's just something that we learned that we have to cope with this new world that we live in. Also, cloud deployments that we're doing, they're becoming more and more complex, right? Because we have all these different teams. They're now in the Spotify model, right? They're all doing Spotify model. And these separate teams are independent. They can deploy on their own, right? They have their own changes. They range different services, of course, different applications. These applications are deployed in different environments, of course. These environments are also coupled to different accounts, right? Accounts for instance, production will probably be a different account for building purposes. And those are also running possibly on different providers, right? You could be deploying on Amazon and Google at the same time, but surely they will be deployed on different availability zones, and in those zones, different regions, right? So just being able to grasp where your application is and in which state it is at a given moment in time is very difficult, right? Especially in an enterprise that has big size. So this is another lesson that we learned. It's really complex to kind of deal with that. So my animation super slow. There we go. So it should also be easy to roll back, right? Because things eventually will go wrong with this complexity, right? We have that many more deployments, and they are so much more complex, things will go wrong, right? So it's important that we just have a button that we can click and it just rolls back. But if you have multiple versions in production at the same time, and you have and you have like a process that you have to go manually, it's really hard to make sure that you can easily go back to the version that you were before. Maybe you don't even know which version you had before because you had different set of versions, right? Yeah. Which one is it? Nice. There you go. So being able to go back in time, that's a big plus. And does anyone know this one? This picture, yeah?
Yeah, absolutely.
Yeah, the unicorn. Is that from Ruby?
Yeah.
Oh, really? I didn't know that. I thought it was from GitHub.
Yeah, GitHub. But they usually.
Ah, okay, interesting. Yeah, so I learned something today. So, yeah, GitHub uses that as a page when something goes wrong, right? When the website is down. I suppose the idea is that this never happens, so it's a unicorn because that scenario doesn't exist. But unfortunately, it does exist, and especially when we deploy, that's when things could go wrong, right? Because it's the most stable app is probably the app that never gets deployed, right? It's very stable, so you should just never deploy it, right? So if you deploy, you have a bigger chance of having downtime, right? Really obvious. Also during peaks of traffic, of course, but during these deployments, we have to make sure that our blast radius, our possible blast radius, is as small as possible. Right? So being able to deploy during the right time frames and making sure that we've done everything up front to make sure we just have to have that toggle, the deployment toggle, for instance, at that moment when people are in the office, for instance, that's really powerful to have. So these are lessons that we learned that we should have in any tool. Any way we're going to do continuous delivery should have these kind of practices, right? So I'm talking about Spinnaker David. If you're working with any other tool, then having these lessons embedded into your process is really useful. So the principles that we can instill out of this is we want to have immutable infrastructure. Did I miss that slide? Anyway, so we all know about immutable infrastructure, right? Who hasn't heard about that? Right. So I don't have to go into this too far, but baking images, for instance, like AMI instances on Amazon, for instance, that's also immutable infrastructure. It doesn't have to be a Docker container, for instance, or a Rocket container, or whatever you want to use. The idea is that you're repeatable, that you're deterministic, that you have predictability, and that you have this def prod parity, right? Because you use the same images all over. So that's important, right? That's a principle. Also, deployment strategies. So as we are here in this meetup, which is about continuous deployment, I suppose you know these kind of deployment strategies. Now, maybe not this one, which is red-black. That's just because it's a Netflix slide. It was such a nice way of showing it that I decided to steal it, so courtesy to Netflix. But they call blue, green, red, black. Any idea why that would be?
Their logo is red on a black background.
Used to be, right? Because that's the funny part.
It.
That's the joke. They changed it, and now it's red, white. So yeah. So it's still red, black, and you will see that in Spinnaker as well in the code that's full of red, black stuff. Even though they need blue, green. And the idea is that you just be able to deploy a new server group next to the existing one, and you toggle over the traffic whenever you think it's ready to be toggled, right? Benefit here, you can roll back really easily. You just change the load balancer, and Kubernetes, you just change the label. Done, right? Rolling with red, black, or rolling with green is a bit further, right? It's a bit more interesting because you can have this validation phase where you don't want to have this full switchover, but you want to have instance per instance switched over. You can do that by deploying instances one by one and disabling instances of the previous version one by one, and that will give you this gradual rollout. You can also have more sophisticated load balancing techniques. If you have a load balancer that can actually be scripted, then that can also be very interesting. But the idea is that you have manual verification in between the phases. And that's where canary deployments would normally be different. Now, canary deployments, it's becoming a commodity, isn't it? We've all done canary deployment, because actually what people think about when they talk about canary deployments is you deploy your new version next to your existing cluster, and you send it some canary birds, right? So canary birds from in the mines, from way back, right? Where we just have these little amount of people, a little group of people would then be used as testing people, as testing people. So that's kind of the same thing here, although we kind of want to have an analysis stage which is as objective as possible. Right? And if we kind of have this smoke test that we scripted, which just checks this normal flow, then that doesn't give you enough confidence to really say we want to roll out, right? Especially if it's about a critical service. So having more sophisticated techniques for doing that canary analysis to see if this canary is healthy or not, that's the key enabler, right? It's the key difference here. And that's what makes this specific deployment strategy special. And I don't know which. What? Oh no, what's that? There is WhatsApp, so yeah. I don't think it was. Maybe it is. Okay. So those are the strategies. So I mean, there are different strategies. You can have your own strategies, whatever. It's pretty straightforward, right? But having strategies available that you can select, that you can choose from in your tool is important. Now, what Spinnaker does is making sure that all these steps that it has to do to get through a pipeline are completely automated. So when you do that in Jenkins, for instance, there's a lot of Ansible or a lot of Ruby scripting that you have to do initially to get that pipeline in place. Now, Spinnaker kind of gives you a lot of these steps out of the box. So here you can see a pretty common pipeline where we want to have basically looking at the test environments. What's our current version, right? We're going to look into the test environment and see what the image behind the deployed pods or whatever you use services is. Now we take that version, we deploy a little canary in production, right? And then if we see it's good enough, so that could be a split pipeline. We want to wait 30 minutes, right? We don't want to make a hasty decision on this. Then we just check, okay, is it good enough? If a manager or anyone who's capable of giving his judgment says that it's fine, he will do a manual cutover, so he'll say, okay, fine, the canary looks fine. So this looks like the rolling blue-green, right? Then he's going to deploy it in production, blue-green deployment, and then you will tear down the existing canary because you don't need them anymore, right? It's just for testing purposes. You wait 2 hours, you look if everything is still standing. If no smoke comes out of the system, great, destroy the old version, right? Pretty simple. Now, these separate steps, they normally take quite a lot of work to get it right. Of course, you could just simply write a bash script that does this, right? But that wouldn't be very robust, right? And that's the thing that Spinnaker gives you. It gives you for each and every cloud provider, well, major cloud provider, it gives you the benefit of having all this stuff done before, for you out of the box, without you having to try to kind of write it in funky bash scripts, because who actually tests this stuff? When you write a bash script, you just test it by executing it. You don't actually write any tests for it. So having this already completely tested by the community and supported in the tool like Spinnaker is really a plus. And you can see that by looking at, for instance, the deployment to production, just the blue-green deployments, right? It entails a lot of things. So the stage deployed blue-green has a number of steps, and each of these steps, for instance, the disabling of the cluster, has a number of tasks. And all these tasks, for instance, disabling the cluster itself as a task, has a number of operations that it has to do, right? Especially if you have all these cloud providers, these operations become very complex in certain cases, right? So having all this stuff baked into the system, that's really useful. At least that's my experience. So then, an interesting thing as well is that if you can correlate deployment and operation together, while you're doing deployment, you can look at operations, and while you're doing operations, you can look at deployment. That really gives you a lot of extra value, right? So for instance, while you're doing deployment, if you can look at, for instance, this canary analysis, which is a nice example, right? You're deploying something into production while you're doing your deployment pipeline. When you're actually putting something in production, you can look at the metrics that the thing is generating. And then based on those metrics, you can decide whether you want to move forward or backwards with your deployment, right? So that's kind of correlating operations into deployment. But also the other way around, where you're actually in production for a while, right? Something goes wrong. You want to be able to look at your pipeline that was correlated with that specific deployment, and you want to be able to go back with every step and see what happened with this deployment. Did something go wrong? Did we miss something? Do we have to improve our pipeline? Or do we have, how can I look at the codes associated with this specific deployment? So being able to trace back everything is also very valuable. So then we come into Spinnaker, right? Which is basically the whole point of my talk. But the idea is that all these principles that we talked about are the basis of this tool. Right? So Netflix has built a tool called Asgard way back, right? I think it's 2008 or something. Yeah. Yeah. So they had that internal, and then after a while they learned that, well, we kind of learned a lot from this tool. We kind of need to build a new tool from scratch that kind of has these lessons that we just saw here, embedded into that system, right? And then of course multi-cloud, multi-region, everything that Netflix actually needs, right? So Spinnaker itself is being worked on by a lot of different companies, and of course Netflix is the biggest one since they created the platform. But then Google quickly spent a lot of manpower on this. I think it's currently a team of 13 full-time employees are working on Spinnaker specifically. It first started out as a 20% project. They do this 20% thing, right? But then quickly they saw the value in the project, and now they are actually the biggest contributors. So Kubernetes support and any of the Google Cloud environments you can deploy to are very well supported. And then also Azure, of course, is supported. So Microsoft has spent a lot of time into it. Pivotal as well. And for Pivotal, we have included support for Cloud Foundry. So also if you work with IBM Lumix, for instance, or HP Hellion, which are also distributions of Cloud Foundry, you can also easily plug in with Spinnaker. But also Oracle. Is anyone using Oracle as a cloud planner? It's that, isn't it? Anyway. Also other companies like Target, for instance. So really big company, super big enterprise in America, and they have spent a lot of time on also contributing to features. Of course, the features that they needed, but they were also open sourced and also available for all of us. So that's useful. And there's also Armory. I don't know if anyone heard about Armory. That's actually a company that takes Spinnaker and makes a service out of it in the cloud. So you don't have to deploy it yourself. You can just use it as a software as a service, and that's really cool, right? So this is super recent news from yesterday. You can see it, March 12th. I don't know if it's zoomed in. Yeah. So it's from yesterday. So Netflix and Google have jointly contributed Spinnaker to the Linux Foundation. So it's now under the newly created Continuous Delivery Foundation. So as you guys are all interested in continuous delivery, you now have a foundation that you could look into, right? Another foundation. So it's part of the Linux Foundation, just like all the other foundations. And in that foundation, there's also currently Jenkins X and the Tecton project, which I don't know, but Jenkins X, so that's interesting. So, timeout? Oh no.
It's the Mac going to sleep.
So which companies are using Netflix? Netflix. All of them are using it. No, which companies are using Spinnaker? I think someone in the room is using Spinnaker, right? Is anyone using it? And you want to share which company?
Ball.com.
Ah, Ball.com, nice, I didn't know. We should put it on the slide, right?
Oh yeah, definitely.
Yeah, you can also request that.
Top one.
Oh yeah, of course. Yeah. I mean, on top of Google, right?
Yeah.
So yeah, Google is also using it. Netflix, of course, themselves. Waze as well. And Waze had a nice talk from Google Cloud Next from I think a month ago in America. They've talked about how they use Spinnaker at humongous scale, at 0 world scale. But also other companies like Under Armour have really contributed and are using it heavily, and some other companies as well, of course. So that's interesting. And with Cloud Development supported. So Cloud Foundry, Kubernetes, Azure, Amazon, you can run it on OpenStack. You can run it on DCOS, so from Metasphere, on Oracle Cloud, but also on Google Cloud Compute Engine and App Engine. And they are looking currently into supporting the Alibaba Cloud, for instance, if you're into Alibaba. Could be right. So who's a Java developer here? I already asked this question. So all of you will be interested in the internal structure because it's all Spinnaker, which is nice. It's very familiar. Now all these applications are kind of microservices, right? And they all have their own specific purpose. I don't want to go into all of them, but one interesting one is this Kayenta one over here. That's the one responsible for doing the automated canary analysis, which I will talk about. So the major feature here, which I want to talk about, is safer deployments. So the thing about this this platform is that it can allow you to go fast to production over multiple clouds and complexity, but allows you to do that safely. Of course, we can go fast to production. Everyone can go fast to production, right? That's easy, but it's reckless as well in most cases. So this platform gives you features to make it safe. One of the features is easy rollbacks. So you can just quickly restore to a previous version, and it will tell you what it will do, right? Which is interesting. So the actions that it will actually execute, it will give it to you up front, so you can make a conscious decision. And you actually have to acknowledge that you want to do it, because there's sometimes a big impact, of course, to roll back features. But you can do that really easily. Also, deployment windows, we talked about that. So if you have a graph of, for instance, your traffic, yes?
I have a question about the rollback.
Yes.
In my head, I have it like, well, you have stateless applications, and then anybody can do a rollback if it's easy. Or you have one that modifies it does an alter table on deploy, and then it's difficult.
Yeah. So
Which one?
zero. Well, this is completely up to how you design your application. So zero downtime database deployments, database related deployments are all about how you design your change in relation to the database. So as long as you're forward and backward compatible with your change that you do, then it's fine, right? And you can do that as separate commits. That's the idea. So you have to change the way you develop to be able to cope with that. It's a different.
But how does this change? Then I'm not really sure what this adds, because I can already do this.
Yeah, but it's easy in just a case where you have a number of instances deployed in one namespace in one server group, for instance.
Yeah.
Right, and you want to roll back to a previous one.
Yeah.
Right. That's super simple, right?
Yeah.
But there are cases where it's much more complex, where you have multiple versions at the same time running in different availability zones under different accounts. And if you want to roll that back, I mean, that's kind of the idea of having a pipeline which has to distribute deployments across multiple clouds, not necessarily multiple clouds, but multiple availability zones, multiple accounts in most cases. So that's kind of difficult, and that's why this is easy. But I have to agree with you, in a simple case, rollback is simple.
Yeah.
And that's, but unless you kind of design your application in a way which isn't compatible with a rollback, which, for instance, deletes fields in a database. Right?
Thank you.
Yeah, but there's a lot of resources on the internet how to do that, how to change your application so it doesn't kind of prevent you to roll back. So having this deployment window allows you to look at your graph of your traffic and then correlate that graph with certain time frames where you want to deploy. So let's say here in this case, I want to deploy between this time and that time, right? And then you can also link that up with the time that you're in the office. Actually, here, it doesn't show it to you, but there's integration as well with that statistics from your application. So it's called a CSC, which kind of gives you the traffic of your application, maps it onto the calendar that you want to deploy. So it's really easy to then pick the right dates, the right time frame within the right date. And then you can also say, I want to prepare everything up front and halt my pipeline up until you have the right time frame, and then just continue that. And you don't have to do all the preparation. Right? You can just get over to doing the right thing. So also chaos monkeys. Who has ever done a chaos chaos monkey deployment? Okay, who heard about it? that's sweet. Yeah, me too. I've run it in QA, which is kind of the. But you have integration with chaos monkeys, right? So the one thing that people miss when they do chaos deployments that I've seen, even at banks, right, is that they run a chaos monkey and they're very happy that they run it, right? They're like proud of themselves, but they don't check the results. They don't assert that whatever the chaos monkey has caused has not been detrimental to your deployment. So that's kind of something you have to think about. So here as well, you can run the chaos monkeys, but then still make sure that you draw lessons out of it. And Netflix has this whole tool for instance, AP deployments and chaos monkey deployments, where they can assert whether the chaos monkey has, for instance, caused latency on the network, didn't actually cause any latency for the user. And that's the key here. So that's not in there. So the canary analysis, which the demo will be showing, we're looking at this, which is something pretty user-friendly. It's could look like that. My demo will not look like that because we don't have the time to do that. But as you can see here, you have a bunch of metrics that you can gather, and it will compare on this side. As you can see, the baseline is in whatever brown color that is, and canary blue, right? And it will kind of try to keep track of what the canary does compared to what the baseline does, and then kind of make a conclusion based on that. And as you can see here, there's a bunch of metrics that I thought it was too high, or some that I thought it was okay, it was a pass, so it was fine, didn't see any problem with it. And eventually, it said, okay, the canary score is, in this case, 58, which is too low. Right? And Netflix often go to, I think, 95% when they want to roll out. So if it's under 95%, they roll back. Right? So, cool. So more safety features are in there as well. Cluster locking, which means that if you're doing something with a cluster, you don't want some other process to act upon that cluster. If you think about 4,000 deployments a day, this is something that can happen a lot. So you have to make sure you have this this deterministic approach to your changes, right? That you don't have this contingency, and you don't have this contention on your cluster, and that you also have some sort of protection against these race conditions that could occur. Yeah, we can have traffic guards. I'll show you one, which makes sure that if you're in production, whatever you do, make sure you always have at least one or two instances in each availability zone left, right? So you might do a rollback, fine, but doing that rollback, you might actually bring everything down. So we don't want to have that at all. So whatever you do, traffic guard will help you to protect you. A manual judgments, so where you can have this manual button that you can check, that you can press, where the gut feeling is involved. It's interesting as well to have gut feeling in there, because we can automate everything we want in continuous delivery. But there's no such thing as a gut feeling, right? A person will always have a different context than a machine, right? The machine might know a lot about your pipeline and your artifacts and the metrics and whatever, but maybe you know about a certain thing that some person changed somewhere else that the machine doesn't know about, right? So having that manual check is still interesting. And you might call that continuous delivery and not continuous deployment, but still it's interesting to have that option there. Conditional pipelines and stage execution, so you can have a lot of different conditions set up, just like in Jenkins, of course, and notifications to any kind of communication hub that you want to use. We also have a tool called Halyard in Spinnaker, which allows you to set up the Spinnaker on any environment that you want pretty easily. So it's a deployment lifecycle management tool, but it also allows you to tweak the configuration really simply. So I've heard as well about, I don't know who was it, that somebody built a tool to manage Halyard, which is kind of cool, you know. But this is also something pretty new. It's been, I think, 1.5 years now it's been released, and it's primarily built by Google. It also works as a bill of materials because we all have these microservices, you know, the different microservices that shouldn't Spring Boot logos, right? All different microservices, they all have their own version, and they all communicate with each other, so you want to have some kind of, you want to keep track of the right set of versions, right? That work together well. So coming up, up what's in the pipeline. So Spinnaker CLI. So there's a Spinnaker CLI for now, but that also kind of supports pipelines as code, and that kind of supports the whole configuration as code as well. Currently you can do that already in certain form, but it's not fully supported yet. Declarative CD, so you have a lot of declarative tools, right? So Kubernetes is kind of declarative, where you define a manifest, which will then say, I want to have 3 pods at all time in my environment, and it will just figure out how to do that. If that means you need to spin up new pods, it will do it, right? Ansible in a way also works like that. So we could say we want to define each step we want to do towards getting into production, or we could say I want to have my application deployed to production. I want to have a canary deployment to figure it out, right? And then Spinnaker will just create its own pipeline behind the covers, and it will just do all its magic, right? If you want that, you can do that. You can still, of course, work in the imperative way. More cloud platforms, like I mentioned, the Alabama cloud and perhaps other clouds as well. Support for artifacts, so now you could get the deployable artifacts from Jenkins, send over to Spinnaker, because Jenkins is focused on CI. Spinnaker doesn't do CI, right? So it will just get an artifact that's been built by another tool. Then that's the way of dealing with artifacts, or you could get something from a Docker registry. That could be an artifact. So these kind of sources, there are many other sources as well. They are abstracted by the artifact idea. So that's kind of what they're building on, they're working on. Then comprehensive provisioning support for canary stage as well. You'll see that our canary stage, for instance, will spin up a baseline and spin up a canary, two new instances, and then they're being torn down after the canary. We actually don't want to do that manually. We want to have that completely done for us, because that's always the same thing. So we want to have that support as well into the stage itself, and working on the community, for instance, as well with the Spinnaker Summit. So there's a summit which you can go to, where all contributors, all the community members are there. So how much time do I have left? I don't know. When do I have to? 15? Well, I'll stop it now. So if you're interested in like Andreas' idea of continuous delivery evolution, this is an interesting slide where you see all these funky buzzwords, right? that you could do, like chaos engineering and anomaly detection, you know. So you could judge for yourself in which stage you are. Cool. Okay. So demo, right? Interesting part. So I'm gonna need your help as well to help you with the demo, right? So you can use your phone and you can go to bit.ly or to this IP address /cd.amsterdam, and then you would normally, if everything is still fine, if things didn't burn down, you would normally see a page, right? Which is my application running production. Well, production. Let me go to my slide. Is it there? Right. Is it working? Yes? Does anyone know what kind of thing is in?
Could you share one more time with that, please?
Like Rick?
Yes. It's Rick, yeah. Pickle Rick, indeed. Okay, so some people will just think like, what the hell is this? So everyone has a link. So bit.ly/cd.amsterdam. So it's kind of based on this show called Rick and Morty. So now better the question would be, who doesn't know Rick and Morty? Interesting. So you're gonna learn something really cool. You might not be interested in Spinnaker at all, but if there's one key takeaway today, it's Rick and Morty. So it's just this mad scientist with his nephew, right? Who takes him into intergalactic adventures, right? It's a stupid cartoon, but it's really fun. And I will have my two protagonists for my blue-green deployment. I will be doing a blue-green deployment with a canary face. So the green deployments will be Pickle Rick, right? So here you can see Rick, which is the same guy as before, you know, he transformed himself into a pickle because he doesn't want to go to family therapy. Now that didn't work really well, but you see, if you look at the episodes, it's pretty fun, even though I can't really explain it. So that's the green version, because it kind of looks green, right? And then we have also the blue version, and who might guess what the blue version might be? It's also a character. Ah, yes, Mr. Me6, go on. So Mr. Me6, yeah, the character Mr. Me6 is interesting because it's like a genie in a bottle, but it's in a box. And you can kind of ask for his help, and he will help you to do whatever you want. But the problem is that he doesn't really want to exist. His sole purpose in existence is to help you perform whatever you want to perform. Right? But the problem is, if you can't perform it because you're too incapable of doing that, and he will keep existing. And then he grows old, and he grows grumpy, and he starts to tear down stuff and starts to make issues, right? So that's kind of a great candidate for a failing kind of canary deployment, right? Because Mr. Me6, as long as it stays in existence, it will like kind of tear down stuff. So this is going to be our deployment that is misbehaving, right? So that's the green and the blue. Okay, spend a lot of time into this, so you'll see. Now I have two demos. I have one with Go and one with Spring Boot, but as we don't have that much time anymore, I'll take the Go, because Go is much faster, unfortunately. Even though I work for Total, which, you know, the Spring Go is faster. So it takes about a couple of seconds to spin up a Go image, while it takes like a minute for Spring Boot. But of course, Spring Boot can do it all more, I suppose. And Frame, right? What I will show is Google Cloud Platform, right? So Google Cloud Platform, anyone uses that? Google Cloud Platform? Okay, a little bit, right? So you can have a Kubernetes cluster running on there really easily, right? So I have that. I have my cluster, which I call Spinnaker. I deploy Spinnaker in the cluster, and I am deploying my applications on the same cluster. It's really pretty straightforward. So you can see here that my microservices are currently deployed on the cluster. The microservices are called Spinnaker, but also my own. Okay, it's to load. This is a network. Nothing to do with the cloud. So as you can see here, these are all my microservices, right? So the ones that I showed in that nice slide with all the Spring Boot logos. And I have some Spinnaker Demo ones. So I have the ones from Spring Boot, and I have the ones from Go. So I'll be using those as well. So you see I have a dev one and two prods. So now I have also used the build platform from Google Cloud Platform. It's like a simple version of Jenkins. I mean, a really simple version of Jenkins, because it just does building and then pushing to Docker registry. But that's enough for me, so I'm using it. And you will see if I change my application, it will go pretty quick. Then I have Spinnaker here, and if you look at Spinnaker, we have this infrastructure tab. And that's the power of Spinnaker. It knows about all your applications, all your instances, in all your clouds, in all your regions, and all your accounts. And that's something that Jenkins can never do. And that's the big difference, in my opinion. We used to, in Spring Cloud, if you know Spring Cloud, we used to work on a tool called Spring Cloud Pipelines. And that tool was basically looking at the tags in Git, because Git was our source of truth, which tag was currently deployed in production. But the problem is that you don't always have one-on-one mapping between what's in production and the tag that's currently the latest one, or whatever tag you select in your Git repository. So that kind of doesn't fit the model, especially with these rollbacks, right? That you kind of can't really find out anymore what kind of versions are where, right? And that's what Spinnaker can offer you as well. It has state inside, and that state is the entire cloud environment. I mean, your application in any cloud, any region, anywhere, right? So as you can see here, I have my Kubernetes account linked up. I am only looking at the default region where I deploy it, which is, you know, suppose Belgium or something. But it can show any region where my application is active in. It can also show, for instance, my bare metal on-premise environment will also be visible here, right? That's pretty powerful. So I can deploy in one pipeline to all these different environments. Now here, I currently have, is this visible? In the back, is it visible? Yeah? So here you can see that my dev environment has just one instance, and it's version 60. And here in the production, I have version 4, which I can easily roll back to version 3. Right? So my version 3 is still there, it's just disabled from the load balancer. And it only has one instance in this case. Right? So as you can see, 60% of all my instances are currently receiving traffic. Pretty straightforward. Now I have the load balancers, of course, and you can see on the load balancer there is just one instance on each. One version on each. One version. Okay. So delivery. That's what we're doing, right? Continuous delivering. So here I can have pipelines, and I will make a change. I will go through the pipeline. Okay. So I have here my Visual Studio Code. I have my simple Go app. I'm not a good Go developer, so please don't look at the code's quality, but basically it's working. So what I will do is I will switch the version from Pickle Rick to Me6, right? So that's going to be my blue version. I'm going to go to blue. So there we go. And at the same time, I'm going to make sure that it starts misbehaving. And the way that I can measure that it's misbehaving is by looking at metrics. Now, I could use logs, for instance, as a source of metrics as well. Right? That's possible. I could also use CPU and anything you want to use as well. But that's also something that I can use as an indicator of a business problem. Right? So I go to my application here, and I have this print, my log, Me6. Right? At the same time, in each version, I'm logging the names of existing, I don't know if you read this, existing characters from the series. Right? If you're interested in the series, you might recognize a couple of them. And there is a Mr. Me6 there as well. So by default, you're always having a couple of Me6 in your application logs, but not a lot. Every 20 seconds, I have all these logs in there. But now, every call that I will make will have an extra Me6 in there. Right? So this can give us an indication that our application is not actually working as intended. Right? So I'm going to commit this. So I switch to Me6. This is just a git push. Nothing too special. Okay. So I'm pushing this to my repo. If that works, that works. Woo. Okay. So back here, so now I have my cloud built environment, I refresh, and all of a sudden I will have, if everything goes well, an extra, a new build ticked off. If everything goes well. Okay. Wait, that's weird. No. Am I in the right project? Yes. So it's looking to any branch on Demo Go. Right? So as you can see here, it's going to look at any push on any branch, and it's going to look at the cloud build YAML. Now that's the way that the cloud build works. Let's take a look here. And that's worked about, started this noon, so this should work as well. Let me do another commit, right? That's weird. So, that's whatever. Push to Me6. Push. Refresh. Okay, if this doesn't work, there's something with Google. I can of course, yeah. I should have used Jenkins, right?
Did you actually commit and push the changes?
Yeah, so I can show you if you wanted to work with me. So yeah, so I commit, let the message switch to Me6, and I push it, right? So git is shorthand G. So that should do it. It does it all the time in all my dry runs, so that's pretty weird. But I can of course also trigger the deployment manually, right? So so I can also check it by going to an older one where I tested it, right? And that also created one of those. Hold on, check for sure. Will I be git commits? Let me check the git commit. Yes, so this one removes the Me6. Okay, so I'm gonna have to have the older one. So wait, which one was that? So this is the so the 859, okay? So 859, 859. So this one, okay? This one was built before, so I can use that. So the image here is git commit, tab. Okay, this is the same thing, right? Same thing as I've done now. So let's use that one. So this guy is a C534. So let's not count on Google build for that, because that obviously doesn't work for some reason. So I want to start, and I want to use a tag, right? So, oh, you still remembered it? So it's C534. C534. So where's that one? It's the tag. Oh, it's the tag I'm looking for. So the tag is, which one? Is it this one? C5. Oh, it's the same. Here, C534. Okay. This has to work, right? Let's see. I build it manually. Boom, it started. Now, normally, it should just kick it off, right? So now, the dev pipeline. It will deploy to dev, right? Our VCs. So let's see here, configure, what does it do? It looks at the configuration. It looks into the Docker registry. When the pipeline has actually, well, when the build has actually finished, it pushes it into the Docker registry, right? That's where it starts for Spinnaker. And it's going to look for the image with a specific last tag. But now we specified our own tag, of course, right? Okay, so deployment. So for the deployment, here you can see how I configure it. Now I have to say this is the imperative way of defining Kubernetes specification. So you can do this through YAML as well. Right? I suppose people who are currently using it with Kubernetes are often using it by YAML, but this one is nicer because you have this nice visual format, which I want to show you. So here you can see that I use my Kubernetes account. My namespace is default. I go into the stack dev, and my container is Spinnaker Demo Go, and any container which is associated to the thing that kicked off, right? And the strategy is handler. Now, does anyone know what Highland strategy could be? Any guess? You know, because you work at Spinnaker. What do you think? Yeah?
There can be only one remaining.
Yes. Does it say that? Oh, okay. It's correct.
It's just a film.
It's a film. There can only be one, right? So, kind of this pipeline chops off the heads of all the other instances, right? So destroy all the previous server groups in the cluster as soon as the new server group has objects. Right? So great, that's going to happen. It's going to put it under the same dev load balancer. It's going to have capacity 1, right? And nothing else is configured basically. So that's really simple. So let's see, it's running, right? All done in minutes. Is it now? Is it 2 minutes ago? Okay, so they also triggered the other builds right now. I just had to wait like 10 minutes or something. Great, thank you, Google. So yeah. So let's go here. So this is running, right? It should be deploying. Let's see how the deployment is going. Well, I have to zoom out a little bit to make it better visible. So the task status is here. On this side, you can see that we are determining the health providers. Then we are disabling the cluster. We're monitoring the disabling of the cluster. We're then forcing the cat refresh, and we're waiting for the cluster to disable. Then we're shrinking the cluster, right? Which is ongoing. So this one is taking a while to disable the cluster. Right? Yeah, that's done, right? It's forcing the cache refresh, and then it will shrink the cluster. So disabling means that you want to have that version with the cluster. You know, the cluster is like in Spinnaker, it's a version of instances, right? So it's associated with a certain application version. It will decouple it from the load balancer, so it won't receive traffic anymore, and then it will shrink it, right? Did I touch the cable? Yeah, it's back. Yeah. So then it will shrink the cluster to 0, right? That it doesn't consume any resources. So that's all done automatically. So now it's success, right? This other guy started as well, right? But at least we have the other pipeline started now. This other pipeline, what is it doing is it is deploying to production. And the first thing it's doing is finding an image from dev, and then it's also parallelly finding an image from prod. Why? Because we need both versions. We need the prod versions that currently running on production, and we need the one that we want to deploy, the one that's currently on dev, right? So we want to have these two versions, and we want to compare them, right? That's the thing. We don't want to use the canary deployments and compare to the existing cluster of production. If we do that, then we're going to have different metrics, because, for instance, the production deployment might have been deteriorated as well, right? There might have been certain memory leaks on there that take time, and that could actually have an impact on metrics. So we don't want to have that. We want to have 2 fresh clusters, and then we want to do the canary analysis on that. So we deploy these baselines. We don't use a strategy, just deploy them next to it, and then we do the canary analysis. So just let me check if we are already there. Yes, we are doing the canary analysis. So this thing is pretty interesting. Why? Because it's kind of looking at your, let me see task status. It's kind of looking at your application. So the one that is currently on production, the one that you want to deploy, the 2 newly freshly deployed instances, and it's going to compare the metrics, right? So right now, both applications are running on production. Now, if you go to your phone and you go to that endpoint, and I can go there as well through the load balancers on production, as you can see here, the load balancer is now giving us, hold on, to zoom out, it's giving us a couple of instances, the existing production version and the canary and the baseline, right? So if I go to that load balancer address, you can see here, then I should have Rick and Morty. Does anyone has the blue one? Yeah. Okay. So I'm just out of luck apparently. Okay. He's giving me the green one. Maybe it's cached or something cached. So now we should see that the logs are different, right? And actually, we could also see if those logs are taken into account for our canary analysis, right? So here we have the canary analysis. So what I've actually configured is that it looks 2 minutes, every 2 minutes, it looks at all the metrics it's gathered, and then it compares for those first 2 minutes. Then the next 2 minutes, it's going to compare what it learned from those 2 minutes. And then after that as well for the whole thing, right? So each 2 minutes, it's going to make an analysis, and then it's going to give you a score, right? So we pause 2 minutes, so now it's running the canary, right? You can see that's the canary analysis. So we only have 6 minutes in total because I want to keep this demo short, right? So here we already see, oh god, this is not actually working as we expected to work. So we have, let me see the summary here. So this canary score is not above the marginal score threshold. Interesting. Let's have a look at the report, right? So we have some boring system metrics, which are CPU and memory. And unfortunately for this canary analysis, 2 minutes is just not enough to get decent data in terms of CPU and memory. If I would run this with for instance, 2 similar versions, then this would run for 6 minutes, and you would get better values. But for 2 minutes, it's just not enough. However, for the Me6, it already found that, okay, you guys have been refreshing a lot, apparently, because it is 1,233% higher than the baseline. Right? So it's definitely many more Me6 are turning up into this blue version than into this green version. So my canary is saying, whoa, 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 I'm sensing that there's something wrong with this new version, so I'm just going to roll back, right? So this way, you're actually not having anyone else impacted than the persons that are looking at your canary, right? So you could kind of make sure that your blast radius is as small as possible, right? So what happens now is that, of course, this went wrong. Well, you see, canary analysis is ongoing here because of the next deployment of the Google Cloud build that kicked off too late. And here, as you can see a minute ago, we had tear down canary. So in this case here, you can see that we destroy the canary and destroy the baseline. Pretty simple, right? So we want to get rid of these instances because we don't want that to remain in our consuming resources, right? So if you look at here at the application landscape, then you'll see that that has been deployed to versions 18, right? So if I go here to this load balancer, then I will see that I have the blue version, right, which is the one that we wanted, but actually it didn't work. And now the next canary is already running because of that deployment. Now, if you don't do anything, we might actually go further into the canary test. So just don't refresh, and then we might see that actually this deployment is deemed as successful because we didn't gather any page hits, which means we didn't get any extra Me6. So the idea here is that if you have your canary set up well, right, the canary config in this case, the demo config for instance, we'll look at the Me6 and we'll compare that to the different versions, and you can check if the Me6 increased or decreased, right? And eventually, if you want to look into the reason why it failed here, we can have I think it's here, source. You can have the JSON as well, where you can see how everything is being calculated, right? So that's really interesting as well to understand why this canary actually failed. Right? So that's kind of the whole idea here. And eventually, if you have a lot of metrics set up, then it might look a bit like this, right? You can see here different metrics, different results, and they could give you an indication of whether you want to roll forward or backwards. Pretty simple.
Is Spinnaker smart enough to tell you when the data that you're telling that it's using for the canary analysis is just not high quality enough? Like if it's trying to compare 0 and 0.
Yeah, definitely. So good question, by the way, because actually it is part of my demo here. As you can see here, one of the metrics returned fewer than 50 data points, which can reduce confidence in the final canary score. So the idea is that you run it for a couple of hours, right, before you roll out to the next phase, and then you run it again, and you roll it out to the next amount of people, right? So you do it in batches. This is just a demo, so it's going really fast. But the idea is that you can run this for days, perhaps. Right? And Netflix is doing that as well, and that's kind of common quick tool. It's also important to get the right metrics, but things like memory, for instance, that's the power of this judge, right? There's a judge, the canary judge, that's looking at your metrics and comparing it. You could do it as a script, right? You could make some queries to your data metrics collector and then compare. But just making sure that you have exactly the right algorithm to make sure you compare the metrics correctly. Like for instance, memory is really hard because you have this random garbage collector, right? So just making sure, just keeping that into account when you're comparing memory is pretty difficult already. You could figure it out probably, right? But that in itself is already a powerful solution. That you can actually have a decent outcome for that. And so basically, this would be your final solution. Okay, so I have one more slide. So that was the demo. You have an ebook, right? It's a free ebook. You can just download it and read it. It's like about 70 pages. And it talks about what I've been talking about today, but much more in detail. And it's super interesting. It's also a good read. So if you're more interested in this, get the ebook. I also have stickers. So these stickers are, by the way, sent to me by Andy Glover, which is the development manager from Netflix. So you can't get them anywhere else than here in Europe, and in America, of course, as well, if you go to the conferences. But come get them if you want them. And the slides are available on Speaker Deck, and you can also get feedback on Slack. There's a Slack Spinnaker team channel, and also a Stack Overflow if you just use Slack. So that's the post. So thanks for your attention and any questions. Then I suppose we don't have much time, but well, maybe afterwards or perhaps over during break. Over during break. Yeah. Okay. Cool. Thanks a lot, everyone.